Hello and welcome to another video by CloudVersity. My name is Stefan and today's topic is Kubernetes. So everyone is talking about Kubernetes since a few years, and it kind of seems like a necessity for our microservice world. A lot of companies already migrated to Kubernetes or are on their way to do so. And that's why I want to demystify the topic around Kubernetes and give you a detailed overview of what Kubernetes actually is. So I prepared a small agenda for this, and the first point is how container environments look like without an orchestrator, and Kubernetes, by the way, is an orchestrator. Then the next point would be where Kubernetes provide help to us, or which problems does it solve. And then we will have a look at the architecture of Kubernetes and how we can interact with Kubernetes. If this sounds interesting, you have come to the right place. I would say let's roll the intro and then let's dive right into the topic. Welcome back. So the first topic in our agenda is how container environments are looking without an orchestrator. I choose the Docker runtime here. That's why you see the cute whale at the bottom of the page. But there are multiple container runtimes out there, like cri-o or containerd. If you are not familiar with container technologies, I would recommend that you go ahead, watch another video by CloudVersity or choose from another YouTuber and find out what container technologies actually are and how they work, because it will make life way easier for you to understand the topic of Kubernetes. So we know that we can spin up containers with a simple Docker command, but typically our application consists out of more than one container. Okay, so let's run a second container. And let's imagine we are at Netflix. I don't know what the Netflix tech stack looks like, but I can assume that they have way more viewers at the evening. So they probably need to scale up their login and authentication services. And we can do this with Docker as well. It would be kind of a manual task, but we can do so. Problems occur when one container goes down. So we do not really have options to define a state if we just run plain Docker or plain container runtimes. So if one container goes down, we can say something like, yeah, then please restart or stay failed or just stop. But we are kind of limited in what we can actually do. And the worst case would be if our Docker host or our container runtime host is dying, because then our whole application will die and we do not have that many options to do something against it. So that's why we need Kubernetes or an orchestrator. There are different orchestration solutions out there. So one of the most known ones is Kubernetes. Kubernetes was actually developed by Google and it's now open source. But there are other ones like Docker Swarm, Mesos, or OpenShift. OpenShift is kind of a specific one here, because you need to pay for it if you want to use it. But what you can see in the Google Trends picture I throw in here is that in the last 5 years, you can see or identify the clear winner of the whole orchestration or orchestrator race. So Google actually, I would say, won the race here. That's why, or not Google, I mean Kubernetes, but that's why Kubernetes is so known everywhere and everyone is speaking about Kubernetes nowadays. So where does Kubernetes actually help? It solves one problem, which is high availability. If we just run our containers on container hosts or container runtime hosts, because we have typically more than one node, and in Kubernetes there's multiple nodes. And if one node goes down, then Kubernetes will make sure that your workload is running on the other nodes. So it will take over, there's kind of a failover, and you have high availability in place. Then you can scale and secure your performance actually. So you can define, if you want to have 10 containers running for your specific service, 20 or 100 containers. And Kubernetes will make sure that you can, or that the containers will scale up and that they also scale down again if they are not needed anymore. And then we have deployment management. So we can define our deployment in YAML files. And this is great because then we can versionize them in our Gits or in our repositories. So this is one benefit. But other benefits would be that we can actually have pretty easy canary deployments, or that we have rolling updates. So if we want to update a service, there will actually not be a real downtime. So that's great. And security. So Kubernetes has security built in. There's RBAC built in, so which is a role-based access control. And there are other tools you can install on top of Kubernetes. For example, DAX, which is an OpenID Connect provider. So you do not need to create roles, groups, and users in Kubernetes. You can just inherit them from your company LDAP, for example. And there are other tools you can install on top of it, like service meshes. Maybe you already know them. Some service meshes would be Istio and Linkerd. And so you can increase the security even more if you install or leverage from those tools. So how does the architecture of Kubernetes looks like from a high-level perspective? So we have a worker node. That can be a single VM. This can be some bare metal server, anything. And on this worker node, there needs to be a container runtime installed. This can be Docker, Containerd, cri-o, or others. But keep in mind, with Kubernetes 1.20, with version 1.20, Docker support will be dropped because of security reasons. If this is in place, we can spawn a lot of containers on the node. Actually, the containers, or the smallest unit in Kubernetes, is called pods, but we will come to this topic in a second. And of course, if your worker node is just a VM with a single CPU and 1 gig memory, you may be not able to run a lot of containers on there. Of course, that's dependent on your resources you have on your worker nodes. And as I said before, Kubernetes solves problems like high availability, so you can have multiple worker nodes, and you can have a lot of them if you need them. And then you need to have something which controls the worker nodes. And this is known as the Kubernetes master. The Kubernetes master is like the brain behind Kubernetes. And there are solutions out there from the 3 big cloud providers you can choose of, which will actually help you managing your Kubernetes, because they will abstract the layer of the Kubernetes master and they will take care of it. But of course, you need to pay for it. So for example, for Azure, it's the Azure Kubernetes Service, so AKS. For AWS, it's the EKS service, so Elastic Kubernetes Service. And for Google, it's a GKE, for Google Kubernetes Engine. If you want to try it on your own and you don't want to pay anything, you can go to Rancher. So I can really recommend Rancher if you're running on bare metal or you have some VMs you want to combine to Kubernetes cluster. Try it out. Rancher is just great. Okay, so let's go even more into detail. To make up our Kubernetes cluster, we have different components and services installed, or we need to install them. And one of the services we need to have is a kubelet. So a kubelet, or the kubelet, is an agent which needs to run on each host on our Kubernetes cluster. And he's responsible to register the node to our Kubernetes cluster. So he reaches out to the Kubernetes master and says, hey, I'm a new node. And he's also responsible to maintain the pods which are running on the node. And I think that's pretty much it. He also gives status feedback about metrics and so on and so forth to the API server. And then we have the kube proxy. So the kube proxy manages the internal traffic in our Kubernetes nodes so that pods can reach each other and can communicate to other pods and nodes. And then we have the important services. So there are more than those components here, but these are the most important ones. So we have the etcd on the master node. Etcd is kind of the brain, it's the memory of our Kubernetes cluster. So it's the storage where all the cluster information will live in. So what deployment is running where, what about secrets in Kubernetes, everything like this is stored in etcd. And by the way, master nodes can also be high availability, or there can be multiple master nodes, so you reach high availability, and you should definitely aim for, because if you lose etcd, you lose your Kubernetes cluster. Okay, then what we have next is our scheduler. So the scheduler is doing exactly what it's telling us with its name. So it is responsible to validate nodes if you can schedule pods onto the nodes. And he will make sure that if one node is already at 50% CPU usage and the other one only at 10%, and there are no other restrictions, he will probably place the new pod on the host or on the node which has lower CPU usage, for example. Now we have the controller manager, which is a really important part in Kubernetes and the components. So he loops all the time, he loops through the state of Kubernetes, and he will try to reach the desired state. So he will look at the current state and then he'll try to get to the desired state. And there are other controllers underneath the controller manager, which are, for example, the replication controller or the namespace controller. And here, then we have the what is left, the API server. The API server is actually the one where you talk to if you are the developer or an operations guy, someone who is maintaining the cluster. Every command you fire against your Kubernetes cluster will go through the API server and then will be forwarded to the nodes. So you never directly speak with the nodes. Every communication of each component and of you guys will go through the API server. I used the word pod and services multiple times, and now I want to explain what those terms actually mean. So here we have our worker node again. And on the worker node are running pods because it's the smallest unit in Kubernetes. So what actually is a pod? So one pod can have multiple containers in it. Typically there is just a single container within one pod, but you can have multiple containers in a pod. There are multiple reasons why you should do, or why sometimes it is necessary to do so. So for example, now we have here our two pods, and one pod is running 3 containers, and then the other one is just running a single container. And both of them have an IP. So they have an internal IP address where they can talk to each other. But maybe you asked yourself already a question. So if pods have an internal IP and they can be destroyed at any point in time or scaled up and down at any point in time, how you keep track of the IP of any pod in your whole Kubernetes cluster? And therefore we have something called services. So let's think about, we have a front-end service and we have a front end and the back end. Both of them consist out of 2 pods. All of the pods have their internal IP, but if they scale up and down, the IP will change. But you still want to communicate between them, and that's why you need to have a service in place. The service is then capable of load balancing between the pods which are registered to the service. So you can just call the service, and the service will always know which pod actually serves the application or the part of the application you want to route to. And so you have a load balancer built in Kubernetes. So it's that the service actually is a load balancer, and he always keeps track of which pods and how many pods are running there. And it's also there for easy service discovery, because the service name, you can use the service name to identify parts of your application. You do not need to keep track of any IPs. And by the way, the IP of the service is persistent as long as the service exists. So that's a great feature of Kubernetes as well. I mean, you have a load balancer in it. That's cool. Okay, let's have a look at the last point of our agenda. So to communicate with Kubernetes, you need a CLI tool, so a command line interface. And this one is called kubectl. Sometimes it also is called kubectl or kubectl. You can execute specific commands with the CLI tool. For example, you can get some cluster information if you run kubectl get nodes, so you will see all the nodes you have in your Kubernetes cluster. You can also run kubectl cluster info, and then you will see where your Kubernetes cluster is running. Other commands could also be, for example, kubectl run nginx, and you need to specify an image, and then there will be a pod with nginx running. So it's just reaching out to the container registry. Per default, it's the Docker Hub, and it will download the image there, and it will spawn a pod. That's it. It's pretty easy for the simple use cases, of course. And what actually happens behind the scenes is that the command line, or the command you executed with the command line within the command line, creates a YAML file in the background. You could also apply the YAML file, which is here in the picture, which is just 8 lines of YAML, and the pod will also be there. So it would be the same. And of course, you can also create deployments. So in deployments, you can define how many replicas you want to run from a specific part of your application. It's kind of the same. You create a deployment, you give it a name, you give it an image, for example, here nginx again, and then you say how many replicas you want to run. And on the right side, you also can see what the YAML file would look like if you will write it in YAML code. Okay, so here's our agenda again, and I think we covered all the points we wanted to cover in this video. If you have any questions, feel free to leave a comment. And if you like the content, I really would appreciate if you give the video a thumbs up and if you subscribe to the channel so you don't miss any upcoming videos, because there will be a lot around container technologies and cloud stuff in general. So I plan, for example, a hands-on video on Kubernetes in the upcoming future. So I hope everything was interesting for you, and see you soon. Bye.